Always good to see the physical slope. Okay, so when we're given points like this, A and B, we should really draw the slope, because when we just sketch a picture of this, we have an idea whether the slope is going to be positive. Okay, so slope going positive goes up in this direction, left to right, or negative, which means that slope is going this way, left to right. It's going down, left to right, or up, left to right. So if we draw in the coordinates 2, 7, okay, 5, 28, somewhere around there, if we just sketch in the coordinates, we get an idea then of at least we get an idea of the direction of the slope. So in this case, it looks like the slope is positive. So when I draw my slope triangle, I want to find my change in y. The change in y is going to be the n. So in this case, I'm going to use 28b as my end position. So it's going to be 28 minus the starting position of positive 7. Okay, so the change in y works out to be 21 up. Okay, so we've gone up 21 units. Okay, so then I draw in my change in x along the horizontal here. The change in x, we ended at 5. I'm going to write that, just draw that in here. So my change in x, we ended at positive 5. We started at positive 2. So I have a run of positive 3. It went 3 to the right. Okay, so plus 3 here and plus 21 here. So working out the slope then, we can see it's positive divided by positive, so we end up with a slope of positive 7, or I'm just going to leave it as the two parts, because although we can express this slope as a one number slope of 7, we always should remember that slope is a ratio, okay, and it's a ratio of rise to run, so there's two parts to that ratio. So there's my slope. My slope ratio is 7 to 1. And it's positive because it's going up from left to right. Okay, and my calculation also shows me it's positive. So it is good to always sketch a diagram. Any kind of math that you're doing, really, it's always good to sketch a diagram when possible. So what you want to do is you want to make sure you understand where you can find slope. So there's this physical slope that we can calculate, but we can also find slope in rates, because slope is a comparison of two components, a rise to run. A rate is also a comparison. It can be expressed with slope. For example, if we have speed or velocity. Okay, velocity can be calculated as the change in distance or displacement over the change in time. Okay, or we can say velocity can be measured in kilometers per hour. This is a ratio of changes, which then can represent slope. Okay, we have things like density. Okay, these are rates that represent slopes. Okay, so these are slightly different than physical slope that we see in a line here, but it's always good to relate these rates into a physical slope for us to understand. So density is the change in the mass over the change in the volume. Okay, mass divided by volume gives us density, or grams per liter. Okay, is how we measure density. And then there's also the physical slope, like a slope of a roof. Okay, we can say slope of a mountain, okay, which relates to the physical slope that we see in our graphs as well. So slope can be this physical slope. Okay, it can also represent these rates. So if we take a look at the slope of this graph, has physical slope on the graph, but also has a rate when we look at this problem. So here this relationship, I'm comparing the dollars in the bank account on the y and the number of months we have that money in the bank. So it looks like as we keep money in the bank, the bank account is increasing. So if I want to find the slope, I can choose any 2 points and draw my slope triangle. Okay, so I'm just going to arbitrarily choose 1 and 3. Okay, you could choose other coordinates as well. You might get different numbers, but since slope is a ratio, you will get the same ratio. So my change in y, I should always get in the habit of doing my change in y first. The change in y is going to be, I ended at $350 and I started at $250. So I can see that I have a positive $100 change. Okay, so I went up $100. And the change in x, okay, well, I ended at 3 months and I started at 1 month, so I have a positive 2-month change in x. So when I then calculate the slope is the ratio of those 2 components. So the slope in this case is going to be the change in the y divided by the change in the x. And we want to know what it represents. So it looks like the slope is 50, but it actually represents something. Okay, the units in the numerator are dollars, okay, because the change in y is in dollars, and then the change in x is months. So the slope actually has units. So the slope is going to be positive $50 per month. Okay, so this slope ends up being a rate in this relationship. So this relationship of months to dollars in the bank account is increasing at $50 per month, and that increase is what's being described by the slope.